Deep in the northwoods of the Acadian forest, the place I know as home, life returns fast and vigorously with the first sign of spring. And that means it's time to get out of the cottage, head deep into the woodlands, and rediscover a natural world full of marvels. Those marvels can be as delicately beautiful as the simple first coltsfoot of spring. Or they can be as magnificent as the sight of a forest river finally devoid of ice, where drowsing trout rouse with the sunbeams. But those are just the marvels that we can see. If we look smaller, into the tiny world of the microscopic, we will discover waking, renewing life all around us, such as this minuscule crustacean eking out a living, a good living for that matter, upon this river stone. And if you're wondering what it's eating, I'll tell you. It is not so much a substance, but a collection of substances and organisms called biofilm. And as you're soon to see, biofilm is filled with life. Biofilms can be found easily on submerged stone. Simply pass your hand over a cobble in the water. If it feels slimy, there is biofilm. It is easy to collect as well. Generally, you can readily lift it from its stone host by scraping it with a rigid object. I collected plenty to make this episode simply by scraping my test tube cap across the biofilm until I had gathered about a cubic centimeter, which I then dropped into a few milliliters of water to keep the biofilm alive and vibrant until I could return it to my home lab. In the course of scraping some of the biofilm off one of the stones, I had also picked up some of the silty riverbed bottom. I have found that just like with microscopic organisms, microorganisms seem calmer if they are among familiar environments. And if nothing else, providing such detritus on the slide slows down some of the quicker organisms, allowing us to observe them more naturally. Biofilm is a construct of microscopic life in which hundreds, potentially thousands of species come together collaboratively and form a mucilaginous matrix in which they all might live. This allows them to, together, resist the pull of the water and have some defense against predation by larger organisms. And, as one might expect for a substance called biofilm, life is found everywhere within it. Here we have two quiet, still examples of that life. The elongated oval in the center of the screen is a diatom, an organism also known as a living opal, because its exoskeleton is made of hydrated silica, the same substance opals are made from. And just to the upper center left, there is the triangular form of another diatom. This one, though, is no longer alive. However, as the exoskeletons of diatoms are literally made out of stone, those shells can very realistically last for eons. In fact, in the natural world, in lakes and oceans, diatoms serve as the foundation of food webs, and due to their photosynthetic activities, are important contributors to Earth's oxygen levels. But when they exit this life, they leave behind those fascinatingly beautiful opal shells, which then sink to the bottom of whatever body of water they live in, and collect over time, forming substantial layers across millennia. Sometimes people dig up these layers and find uses for them. The very fine abrasive in your toothpaste is often made from diatom shells. And diatomaceous earth is collections of diatom shells that have become so thick they have formed a layer in the earth. These are often dug out and used by gardeners for various reasons, including pest control. So, diatoms are living opals. Let's see if we can get past the harshness of white light to bring out some of their true and beautiful colors. No false color needed here. A simple zoom followed by condensing the white light and then increasing the amplitude of the red, green, and blue channels brings out the shell's opalescent beauty. Elsewhere in the microstory, we find the scene of a calm little diatom rudely interrupted by a racing rotifer. Rotifers are ubiquitous microscopic multicellular animals, most known for creating swirling vortices of water in front of their mouths that draw in food. But as you can see here, they are one of the speed demons of the microscopic world. And I am having a devil of a time keeping this busy little guy under the lens and in focus. Notice the tail-like appendage behind him. That's actually a foot. See how the rotifer moves to one large bit of detritus after another and attaches his foot to the substrate. Rotifers are capable of producing a powerful glue by which they can attach themselves to substrates for stability while feeding. And just as quickly, as you can see, they can detach themselves and get on the move again. Rotifers are notoriously powerful and voracious eaters, like tiny vacuum cleaners sucking in whatever food happens to come their way. Often bacteria, sometimes algae, But they aren't picky, and they are occasionally even known for cannibalizing one another. These diminutive animals have only about 1,000 cells, and with that 1,000 cells, they make gastrointestinal tracts, hair-like structures capable of moving the animal through the water, as well as drawing in food. They are a testament to just how clever nature can be, accomplishing so much with so little. If you want to learn more about rotifers, click the link in the video. Placing another drop of our biofilm sample under a slide, this time with less of the river silt in it, reveals a new and mysterious organism. I believe this to be a hippotrick, perhaps some kind of spirotrick. In the microscopic world, identification is, at best, tricky. Genetics constantly reveals new relationships between organisms, relationships that seem to have nothing to do with an organism's appearance. And there are just so many microscopic organisms. Most species, and by most species I mean 99.999%, have never even been cataloged yet. Let's take a closer look at this one. We'll go up to 200 magnification, but that requires us to drop the beautiful dark field background. Still, at this level of magnification, we can get a clear view of the animal's cilia. They spiral around its body, explaining its peculiar twirling way of swimming. And these cilia are very thick and robust, like one might sometimes see on hippotrichs, which are noted for, among other things, a peculiar walking-like behavior, at least among some species. And it seems to be happily burrowing into this bit of organic matter. I suspect feeding upon the algae that it finds amidst the biofilm. Let's move on. In terms of biodiversity, biofilm is an extremely rich environment, and there is just so much to see. Pushing our magnification up to 400, we find this very interesting organism. It appears to be a form of Ciliophora, and in particular, a suctorian. Suctorians are organisms that begin life motile, that is, they have the ability to move. But as they come into maturity, they lose that ability and become sessile. While they are motile, they have more cilia, but when they become sessile, they lose their surplus cilia. And that may be just what we are seeing here, because if we look at this organism, we can see it has some very long cilia and also some shorter cilia. And while it's clearly moving about a little under its own power, it's not doing so very much. And if this is indeed a suctorian, the reason why is they don't have to move. Suctorians will sit about, waiting for various microbes to pass their way. Then they will use their longer hairs, which are specialized microtubules, to ensnare that prey. Well, more technically, they have toxic extrasomes, which are like little packages of poisons, which they disperse on and around a microorganism that happens to come into contact with a suctorian. This weakens or immobilizes the prey, and the suctorian then uses its specialized microtubules to extract nutrients from the prey. In fact, on the left and right, it looks like this suctorian is already feasting on 2 microbes. There were many, many more species to be found within that single droplet of biofilm. And all that taken from a single cobble in a tiny river within the forest. The biodiversity of this world is truly a marvelously complex thing when you think about it. And if anything, I find that whenever I peer through the lens of a microscope, I'm reminded of just what a delicate and truly amazing thing this world is. Thank you for coming along on this voyage of discovery into the MICROSTORY. The MICROSTORY program is part of the Understory Network, a group of channels devoted to providing education on the science of the natural world. On our MICROSTORY channel, you can find all of our programs related to all things microscopic. On the Understory channel, we study animals, plants, and fungi, as well as issues related to conservation. And on the Sky Story channel, we explore the world of astronomy and that of astrophotography. Our programs are made possible by our many viewers, patrons, and students. And we owe all of you a profound thanks. And if you like what you see here, please take a moment to like and subscribe.